Hi class, let's take a look at example 3. Now in example 3, they don't want us to solve a specific problem. All they want us to do is to write an equation that provides a mathematical model for the situation given above. So let's actually dissect the situation, and in the first deposit here, it says that they started the year with $188 saved. So technically, the first deposit should be $188. And then the subject here, well, in this case, it's saying that they started saving $14 per month. So in the second month, the account is going to have 188 plus the totals of 14. Let me just rewrite the 8 here. And on the following month, they would have, well, technically 188 plus the $14 plus the new $14. And notice that you can rewrite this one without actually adding them as 188 plus 2 times the actual $14. And what I'm trying to do here is create a pattern. For the previous one, you could have said, well, this is 188 plus technically 1 times the values of 14, and then the unit is actually dollars, which I forgot to put on the previous one. So in this case, the equation could be expressed as follows. Now, for this equation, we do want to state what each of the variables represent. So in this case, we're just going to and we're given here what these are actually representing. So we're going to let M equal to the months. And then S, it's going to be, well, the money saved. So the actual equation is going to read something along the lines S is equal to, and we have to start with the original 188. So this will be 188 plus, and then we can rewrite it as M times the values of 14, and then we're including the units. Or if they just want the equation without units, this will be 188 plus 14M. Both of these would be fine. I'm adding the units on the previous one, but both of these are perfectly fine. And we are defining S as the total money saved in the account. That's actually it for 3. Let's take a look at problem 4. So they don't want us to solve anything. They just want us to write the equation that you could use to solve any future scenario. So let's move on to problem 4. Now take a second and read problem 4. And one important aspect of this problem is the units. So they're talking about billions of dollars. And then X represents years after that specific date. Now, on problem A, and then also this is the mathematical model that would give us the revenue for this company. And problem A, they want the total sales from this company in 2011. And technically from 1998 to 2011, this is going to be X is equal to a total of 13 years. So the total sales, and let me just rewrite it. So total sales well, we're just going to have S is equal to 1.3x plus 4.6 with X is equal to 13. So we're going to be evaluating 13, since it's 13 years since 1998, into the equation given. So remember that this gets evaluated in this position. So now we're looking at the values of S. This is equal to 1.3. times the values of 13 plus 4.6. And let me carry the multiplication on the side. So in this case, we have the 13, and we're going to multiply it times 1.3. So this will be a 9. This is a 3. And then a 1 and a 3. So 9, 6, 1. And with one decimal place, I'm getting 16.9. So let me rewrite it. And we're looking at S is equal to 16.9 plus the 4.6. So the total value of S, it's going to be, let me just add it on the side. So plus 4.6. So this is going to be a 5. You carry 1, that's going to be an 11. And then, so I'm getting 21.5, the total sum of those two. So 21.5. And then keep in mind that this is a word problem. So we would just have to say that the total sales on January 1st of 2011 was, and we're talking about 21.5, and remember that this is in billions of dollars. So let me just write it as billions of dollars. So that's how much that company is making. Okay, that's actually it for part A. And part B, they want us to see what year they reached $20 billion. So let me just rewrite the formula here. In this case, we're going to be using, so use S is equal to, and this is 1.3 x plus the 4.6. And they want to know when this formula is equal to 20. And remember that the units are billions of dollars. So technically, we're going to have to solve the values of 20 is equal to 1.3x plus 4.6. And let me start by subtracting the 4.6. So at this point, 20 minus 4.6 is going to be 15.4, which is equal to 1.3x. And then we're going to be dividing by 1.3, divide by 1.3. And let me rewrite it and also flip it so we have the variable first. So we're looking at x is equal to 15.4 divided by 1.3. And what I'm going to do here is multiply by 10. So we're looking at this being 154 divided by 13. And well, we're going to need a decimal approximation because they do actually want a year. So in this case, 13 is going to be dividing 154. And let's see. So it's going to fit once. This will be 13. We carry the subtraction. This is going to be 2 and a 4. And then another 1. It doesn't fit twice. So this will be 13. Subtract. This is going to be 1 and a 1. And point. There's a 0. And then the next one's going to go in there 8 times. Let me check it. 8 times 3 is 24. You carry 2. 8 times 1 is 8. And then 2 would be 10. So in this case, we're going to end up with a remainder of 6. Okay, I'm going to leave it like this because it only, this will just give us the year. So we're looking at 11.8. So in about 11 years, so in this case, I'll just say, so 1998 plus 11, it's going to give us 2009. And let me just rewrite it as that in the year, so in the year 2009, the company the company had, in this case, 20 billion sales. That's actually it for these two. I do want to note that if you're working these problems on the actual homework, this could have rounded to 12 since it's 11.8, but they didn't mention that in the rounding. So they just kept it at 11 when it reached an actual year. So if they wanted you to round to the nearest integer, this would be 12, and then that would change this to 2010. I actually checked the answer just to verify that. No, and they're not rounding. So they just keep the integer value, in this case 11 years. That's it for this problem.